Europe, the mid-1300s, the continent was thriving, trade routes booming, cities growing, new ideas stirring. And then everything stopped. An invisible force began creeping through villages, across borders, through ports and homes. People fell ill overnight. Black spots forming on their skin, fever spiking, families vanishing within days. No one understood what was happening. Some called it punishment from God, others blamed bad air or the alignment of planets. But now, centuries later, science has given us an answer. Through ancient DNA, we finally know what caused the deadliest pandemic in human history and where it truly began. For generations, historians believed the plague began in China, spreading westwards along the Silk Road. But new breakthroughs in ancient DNA research are rewriting that story. In 2022, scientists analyzed human remains from grapes discovered near Lake Issyk-Kul in modern-day Kyrgyzstan, dated to the 1330s, about a decade before the plague reached Europe. When researchers extracted DNA from the teeth of those skeletons, they found the unmistakable genetic signature of Yersinia pestis, the bacteria responsible for the Black Death. Even more astonishing, this bacterial strain turned out to be the common ancestor of all later plague lineages, meaning this tiny mountain valley may have been ground zero for the single deadliest events in recorded history. Here's how scientists confirmed it. Teeth are one of the best places to find ancient pathogens because blood vessels once ran through them, trapping microscopic traces of bacteria when a person died of infection. By grinding the dental pulp into powder and sequencing the genetic fragments, scientists can literally reconstruct the genome of a medieval bacterium. When they compared that genome to modern and other ancient plague samples, the results were clear. Every strain that devastated Europe, Asia, and Africa descended from this same branch. This discovery didn't just identify where the plague started, it mapped out the entire family tree, a biological fingerprint connecting millions of deaths to a single origin. So how did this microbe go from a Central Asian valley to every corner of Europe in just a few years? Trade. The same networks that brought silk, spices, and culture across continents also carried rats and fleas. Inside those fleas, Yersinia pestis thrived. When an infected flea bit a new host, the bacteria flooded into the bloodstream, multiplying at terrifying speed. Victims developed fevers, nausea, and painful swelling. In less than a week, most were dead. By the time the first ships reached Mediterranean ports, the plague had already become unstoppable. And yet, even in that chaos, science has now revealed how precise and powerful this bacterium really was. Modern sequencing shows that Yersinia pestis carried genes that made it uniquely deadly. One of them, known as PLA, allowed it to invade deep tissues. Another, YMT, helped it survive inside fleas, ensuring it could be transmitted again and again. What's more, scientists found that during the Black Death, the bacterium barely mutated. It was so well adapted that it didn't need to evolve. That's why from London to Paris to Florence, nearly every DNA sample taken from victims looks almost identical. A molecular snapshot of a single, unstoppable epidemic. But the DNA doesn't just tell us how the plague killed, it also shows us how humanity survived. When researchers studied the descendants of plague survivors, they found signs of natural selection in our genes, especially in those related to immune response. Some people carry mutations that made them slightly more resistant to bacterial infections, especially in genes like ERAP2, which helps the immune system identify invading pathogens. Those who had this mutation were more likely to survive and pass it on to their children. Over time, these small advantages reshaped the genetic landscape of entire populations. So even today, fragments of our medieval ancestors' immune systems still live inside us, silent reminders of what they endured.
But the impact wasn't only biological, it was psychological, economic, and spiritual. The plague shattered Europe's social order. Laborers became scarce, and suddenly, ordinary peasants had power they'd never known before. They demanded higher wages, fair treatment, and a voice in how they lived. Feudalism began to crack. Religious faith, too, was shaken to its core. Some saw the plague as a divine punishment, others as proof that prayer and penance were meaningless. This loss of certainty set the stage for centuries of questioning. The Black Death didn't just take lives, it dismantled the very framework of medieval life. Even centuries later, its echoes remain. Many of the public health systems we take for granted, quarantines, isolation of ships, citywide sanitation, began as desperate experiments to contain the plague. Words like quarantena come directly from 40 giorni, meaning 40 days, the period ships were once forced to wait before passengers could disembark. The concept of contagion, of invisible agents causing disease, was born from this era of panic and observation. And though we didn't yet have microscopes, the experience of the Black Death planted the earliest seeds of modern epidemiology, the study of how diseases spread. The plague's devastation taught humanity to watch, to measure, and eventually to understand. Today, Yersinia pestis still exists. It hides in wild rodent populations across Asia, Africa, and the American West, a quiet reminder of how easily history can repeat itself. But thanks to antibiotics, the plague no longer defines our world. Instead, it defines our curiosity. Every genome was sequenced, every fragment of ancient DNA brings us closer to understanding not just how we died, but how we lived and adapted and evolved. Because buried within the bones of plague victims lies a deeper truth. That humanity is fragile, yes, but also endlessly resilient. The Black Death once brought Europe to its knees, but from its ruins came revolutions in medicine, in thought, in identity. And now, through the lens of DNA, those long-lost voices finally speak again. They tell us that even in our darkest moments, we are never only victims of history. We are its survivors, its witnesses, and its living continuation.